Okay, the trig, you gotta remember the unit circle. Important identities for you to remember are.
It tastes as good as it smells like. You can definitely do that. There's just like an all mint one. It's like a mouth refresher.
You gotta remember these ones.
Pretty small. I'm gonna do that.
Reciprocal, easy, right?
No.
Piece of cake. You remember those? Yeah.
No.
Come on. Cotangent's 1 over tangent. Secant's 1 over cosine. Easy.
I lost my
Yes?
eraser.
Yeah, I know that.
Okay. Your eraser was terrible anyways.
No,
Doesn't
the one that I
matter.
stole from my English teacher that was good.
Oh.
From Mrs. Taylor?
Yeah, she said I could have it.
Ratio test. Or not ratio test.
It's
Ratio.
only one.
Pleasure.
Why don't you say like one?
Because how would I put that in my pencil?
The most favorite one of all. Pythagorean. You remember these?
Wait, are we doing Trig for the rest of like the year now?
No. Well, yeah, you'll have it in your problems for the rest of the year.
No.
No. Sorry, that's life. You don't really need to know even, odd, although you should know that sine is a odd function, cosine's even, tangent's odd, right? Okay, maybe not. Maybe you don't remember that. You don't remember that?
No.
No.
Oh, not at all.
Sine's even, sine's odd, because it's symmetric across the origin. Cosine's even, because it's symmetric across the y-axis.
Oh yeah, wait, I do remember that.
Tangent's odd, because it's symmetric around the origin. Okay, yeah. But not necessary for you to memorize those identities. And then double angle, sine, and cosine. Remember those. The cosine one becomes very important when we start doing polars. Yeah. But the sine one is important now. And then you don't have to remember law of sines or law of cosines or half angle or sum and difference. So you're welcome. I'm just making you remember the other ones. Right? Okay, things you do need to memorize are derivatives and integrals of trig functions. Do you remember last year when you did these? And did you guys in your pre-calc class like derive tangent, right?
Oh wait, yeah, we did.
And it was tangent is sine over cosine, and then you did quotient rule.
Yeah.
Oh. Probably.
Yeah. Do you want me to
The
do
one
one?
that the schools have. The big
Yeah.
ones.
Okay. So tangent is sine over cosine. So if I want the derivative of this, I go
No, when you
low
should, like, you can't hear anything else but the show.
d high
It's really annoying. I'm trying to learn.
I think you're louder than you are.
Yeah.
minus high times the derivative of cosine. Derivative of cosine is negative sine all over bottom squared. Right? And then you end up having cosine squared plus sine squared, which I told you is an identity you should remember. That's 1. So we have 1 over cosine squared, which is secant squared. Yeah, see? So then you did that with tangent, and I think you did it with cosecant, doing 1 over sine. And then secant is 1 over cosine, and then cotangent was cosine over sine. Anyways, you gotta memorize these. The ones that you should memorize are sine. If you remember sine, tangent, and secant, the ones that don't start with an S, then all the ones that start with a C are like the exact same but negative. So like the derivative of sine is cosine. So the derivative of cosine, which starts with a C, is negative sine. The derivative of tangent is secant squared. So the derivative of cotangent, it starts with a C, is negative cosecant squared. And then the derivative of secant x is secant x tangent x. So the derivative of cosecant, because it starts with the C, is negative cosecant, I forgot an x here. Cosecant x, cotangent x. Got it memorized? Yeah? Okay, cool. Now let's go back to unit 1. Ready? Proving proving continuity. How do I prove continuity?
There's like a y for like every x.
Ah, jeez, no.
Wait, no, I
What?
forgot.
Gosh, guys. It's like I've taught you
The limit
nothing.
exists. There's a limit.
Yeah.
Okay, limit exists. All right.
Oh my
And then
God,
what
I
else?
remember this.
Continuity.
And it equals the f of 0.
Good. Man, I'm gonna retest you on some standards.
No, Miss Lloyd, don't do it.
I'm gonna do it.
Oh my God.
That's
Sine 0, because this is the left one. This one's tangent 0. This is tangent 0. Do they equal? Sine of 0 is 0. Tangent of 0 is also 0. Tangent of 0 is 0. Again, 0. Yes, yes. Equals, equals, equals. Continuous. Exclamation point. Is it differentiable? How do we prove differentiability? Unit 2. Look at that. Everything comes back.
We said the limit is equal to the
Of what?
The right limit.
the limits.
Okay. Of what? God, why don't you know?
This is like a year ago.
It was just 2 months ago.
That's
1
a lot.
month
That's a lot
ago.
of
That's a lot of
information.
months.
That's 4 weeks of information. And all my different
The only
thoughts.
thing on my mind now is like 3 months.
Thank you. The slopes should equal. Duh.
Oh, see, I was gonna say that.
Oh, you didn't. Okay, so what is the derivative of sine?
Cosine.
Cosine. What's the derivative of tangent?
Secant squared.
Secant squared. Okay, cosine of, oh, I should have put 0 in here. Cosine of 0 is
1.
1. Thank you. Secant squared of 0 is
I don't know.
1.
yeah, 1. Secant is the reciprocal of cosine. If cosine is
Oh, yeah.
1, then secant will be 1. 1 equals 1. Differentiable.
Yay.
Yeah.
So
Do you remember now?
Barely.
Maybe not.
I
I,
don't know how to spell
I'm
differential.
a terrible teacher. This is why you just shouldn't have me anymore. That's why I'm gone for the next 2 days. Because yeah, exactly. You'll see what it's like without me.
wait, are we just gonna watch videos? Like the film video?
Yeah, film videos.
That's what Miss Rowland did last year. She didn't know anything of
She didn't what?
She didn't learn the content because like she taught like algebra 2. So like she didn't really know like recalc stuff. So she just showed us videos.
That's not true.
Escalates videos, yeah. That is a fact.
Well, you're good. You're okay this year, right? You're surviving.
Yeah, you just did not need to.
Success.
I mean, I'm just saying it's
That's
related.
okay.
Like videos. Like,
All right.
just reminded me of
No, but these videos will be of myself.
it. Yeah. So like
Because
you actually know.
you'll hear me talking. I'll sound like a child on these videos. Yeah. Have you ever watched my videos?
No.
Can't say I have.
No.
Oh God, why do I do all this stuff for you? You ungrateful children. Okay, let's take the derivative of all of these mamma jammas. What's the derivative of sine?
Negative calls.
Cosine.
No, positive cosine, because it starts with an S.
Oh,
You don't change the sign unless it starts
Oh,
with
yeah.
a C. So cosine is
negative.
negative sign, so this becomes plus sine x. Change the sign. For all the C's, you change the sign when you're doing derivatives. Not true when you integrate. When you integrate, it becomes completely backwards.
Yeah.
Okay, this one I have to do.
Low D high.
Yeah, low D high. Low. Derivative of tangent. Secant squared. Low D high minus high. D low. Derivative of x plus 1 is just 1, so let's not write it. All over x plus 1 quantity squared. Okay, that's it. You can't simplify it. Number 3, what's my derivative? Yeah, 0. Because what's sine of pi over 4? Root 2 over 2. So the root 2 over 2 over derivative of a number is 0. Okay. You think you can do 4 through 8?
Probably not.
Okay, you try it. What do you mean? No more hand holding. Not gonna be in your life all the time. You'll have to learn to live without me.
You have to simplify 4.
I don't think you can. Unless you want to pull out you could factor out an x squared, but
Sure.
nah.
No thanks.
No thanks. Eight is gross. What? Anybody stuck on anything?
I'm not using her. I'm a good friend of her. I listen to all her issues. I'm not using her. I'm
Wow,
usually
Megan
nice to her.
sent stuff. Oh. That's crazy. How city shit is it, right?
No.
Just stop doing that.
It's kind of hard because her mom's was
She doesn't have her license?
Your mom?
What?
Your mom?
No, my mom has her license. My friend who used to drive me to school every day, she doesn't have her
That's awkward,
license.
bro.
So like her mom's like in the
illegal.
car right next to her. No.
Oh,
don't-
she's a permit.
She's a permit.
Yeah.
It's not illegal. Her mom's in the car. It's just kind of awkward because her mom's.
That's funny.
Yeah.
But so that's why I stopped riding with her. 'Cause I don't do it.
That's crazy.
You see the end too.
I mean, a ride to school was better.
Magic.
That was amazing.
Okay. Questions on 4? No. How about 5? I did product rule for this part. 6, quotient rule. 7, I did quotient rule, but if you wanted to, you could make it x tangent x, right? And then do product rule. Because I think that it'll
This is boring to you.
No, I'm just tired.
I'm glad.
that probably looks nicer than that one. But I guess if you simplify this one, you would get this one. Do you remember trig proofs?
No.
Oh.
No, yeah. Not
Yeah,
at
so
all.
like if you simplify this, you could get that. I love trig proofs.
I know.
Yeah. It's like solving puzzles.
It's like solving puzzles.
Maybe. I did a 1,000-piece puzzle the other day. I lost the last piece. I know. It
You have
crushed me,
notifications
yes.
for the vocab.
But that's so upsetting. Like,
It was so upsetting,
Wait,
yeah.
it's impressive.
I know.
10,000?
No, just 1,000.
Oh, and 1,000.
Just 1,000.
I do 1,000. I used to be able to do 1,000.
It was a puzzle of a library. See, I'll show you. That's the piece that's missing.
Rule?
I can't find it.
I have to do jigsaw puzzles.
Yeah, what? Like,
Why? Because it's fun.
Numbers?
yeah, some
fun.
Puzzles are great. Okay, anyways. All right, questions on that? No? Let's do this one now. This will be the last one, then we'll go to lunch and then we'll come back and finish the rest.
Hello?
Okay, so we want a tangent line, right?
Yeah, what
And
do you call
a
me,
normal line. Normal
bro?
line
Yo,
is
I'ma
what?
slap you. I'ma slap you, bro. Yo, don't call me again, bro.
What's the normal line?
I'ma slap you, bro. Slap the turkeys out your neck.
Oh, yeah. Nigeria was calling me.
What's normal line? Perpendicular to tangent.
Yeah, you said hello a bunch of times.
Okay, so,
Wait,
oh
Miss
sorry.
Mary, what did you write?
Can't see it. Perpendicular to tangent. This is a perpendicular symbol. Okay, so what do I need for a tangent line? This is unit 2. What do I need for a tangent line? Slope. Okay, so I need the derivative, right? So how do I take the derivative of these things with x's and y's in it?
Implicit.
Ah, implicit.
Nah,
3y squared
I knew it.
dy dx. Yeah, I know. It all comes back. Then I gotta do product rule with this one. A lot of you, when you were doing standard 5, forgot to distribute that negative to both pieces. So remember, it's negative x times 2y dy dx, and then it's the negative goes to the second part too. So minus the derivative of x is 1, so 1 times y squared. Okay, so that negative goes to both, and then we do plus, and the derivative of cosine is negative sign, so maybe I should have said minus sine of xy, but then I have to do chain rule and multiply that by x dy dx plus y times 1 equals,
2.
no,
Oh, 0. 1.
Yeah.
1, 0.
0, right? Okay, so we have that. Now, should I solve for dy dx?
No.
Good. No is the right answer. What should I do instead? Yeah, we should plug 0 in for x. Let's also find out what y is. So let's plug 0 into here. Y cubed minus 0y squared plus cosine of 0y equals 2. So I have y cubed, 0y squared is 0. What's cosine of 0? Plus 1 equals 2. So y equals 1. All right, cool. So now at this point, you're right. We don't solve for dy dx. We plug 0 in and 1 in for x and y in here. And then it should be a lot easier. So if I plug 1 in, it's 3 dy dx. If I plug 0 into this one, it's just 0. And then minus 1 plugged in here, so it's minus 1. What's sine of 0? 0, so all of that is nothing. So equals 0. Much nicer. So 3 dy dx minus 1 equals 0. So our slope is 1/3, right? So what's my tangent line? Y. Point slope form, guys. Y 1 equals 1/3 x minus 0, so we can just say 1/3 x. And then give me my normal line. Y minus 1 equals -3, because we do negative reciprocal. X. Cool. Got it? All right, when we come back, we do integration.
Why did you apologize to her? Is she the one that
So when we're integrating, basically, you got to remember all these derivatives because the integrals are backwards. So the integral of cosine is sine. The integral of sine is negative cosine. Yeah, so it's reversed. The integral of secant squared is tangent. The integral of secant tangent is secant. The integral of cosecant squared is cotangent. And then the integral of cosecant cotangent is negative cosecant. So really, the c's are always the ones that change, except for these two. These two get flipped. And so it kind of messes you up when you're doing integration of sine and cosine to remember which one's positive and which one's negative. So what we say is, if you want to remember the integrals and derivatives of sines and cosines, write this little chart. Like, you can even just do S. SC, negative C, S. And if you want to take the derivative, you just work your way. If you want the derivative of sine, it's cosine. So you just work your way down if you want the derivative. And if you want to integrate, you work your way up. So the integral of negative cosine is negative sine. So if you write that chart, then that helps you figure out your pluses and minuses for sine and cosine. Otherwise, the c's are the ones that stay negative. It's just the sine and cosine that are flipped. Okay, let's do a couple of these regular basic integrals. The integral of 2 cosine x is, the 2 can come out. So if we look at the chart here, the integral of cosine is sine. So it's 2 sine x plus c. Okay. All right, for number 2, this is sine of 4x. So 4x is your u. So if you were to do it all out, you make u 4x. Guys, can you stop talking? I can not hear myself. So it becomes sine of u, and then dx is du over 4. Okay, so really you're pulling out a 1/4, and then you integrate sine. The integral of sine is negative cosine, so we make this a negative 1/4 cosine. We go back to x because it's an indefinite integral, and then plus c. Okay? But I would like you to get to the point where if you have a linear function in here, you don't have to do all of the steps of u sub. You just know to pull out the 1/4. Since the derivative of 4x is 4, you should pull out a 1/4. Okay, but you can only do that if it's linear. If this was 4x squared, you couldn't pull out a 1/2x. Sophia.
On the free response, would we be allowed to just skip the du stuff?
Yes, please.
Okay.
Yes. Yeah. If it's a quick one, then just skip the whole process of writing u du. So for this one, let's talk about this one. This is a linear function 1/2 x inside, so that's our u. What's our du? 1/2, right? So we're gonna divide by 1/2. So instead of dividing by 1/2, it should be multiply by 2. Okay, then integrate cosine. So if we look at our chart here, the integral of cosine is sine. So it becomes sine. And you go back to x. So 1/2 x plus c. Then you don't have to do the whole writing out the u sub part, which takes a long time. Okay, 4. This is a linear function in here, right? So what's the derivative of x plus pi over 4?
1.
Just 1. So we're really pulling out, we're dividing by 1 on the outside, but dividing by 1 doesn't do anything. So when we integrate sine, we get negative cosine. And then the inside is still x plus pi over 4 plus c. Okay. Do you get the quickness of that? You got to get kind of quick on it.
We have to memorize the integrating.
Yeah. So if you want, just write it on the side here as you're doing this. Go s, c, negative s, negative c, s. And then when you want the derivative, you go down. If you want to integrate, you go up. Right? So this is derivative on this side, integral on the other side. Okay, so this is a linear function, right? Yes? So what's the derivative of 2x minus 1? 2. So I should pull out a 1/2. We integrate cosine, so using this chart, what's the integral of cosine? Sine. Go back to x, and then add a c. Okay, are you with me? 6. This is also a linear function. What's the derivative of my inside? Negative 1, so let's pull out a negative 1, and then pull out the 3 as well. The integral of sine is negative cosine, so we'll make that a plus 3 cosine. And then go back to pi over 3 minus x plus c. Okay? What's the integral of secant tangent? So the derivative of what is secant tangent? Secant. So the integral of secant tangent is just secant. This is cosecant, so it starts with a c, so we're going to make it negative. And then the derivative of what is cosecant squared? Cotangent, yeah. Plus c, okay. All right, number 9. This is a 2x. 2x is a linear function in here. So what's the derivative of 2x? 2. So we should make this 1/2. Keep the 5 out too, so we'll make it 5/2. What's the integral of secant squared? So the derivative of what is secant squared? Tangent, right? And we go back to x, so 2x plus c. Am I going too fast?
No.
Okay. 10, what do I do?
Lodi high.
That's if I were going to do derivatives. But we're integrating.
You can change it into 4 cosecant squared.
Yes. So I know the integral of cosecant squared and sine squared I can rewrite as 4 cosecant squared. So use that reciprocal identity. Dx. Okay, then we actually know the integral of cosecant squared. That's negative 4. And we already set it up here, cotangent x plus c, right? Can I redo 11 too?
Yeah.
That becomes secant squared 4x plus 1. Okay. That's a linear function, 4x plus 1. So what can I divide by? 1/4. Integral of secant squared is tangent. Go back to x. And then plus c. Right?
This isn't that bad.
Yeah. It takes just a little.
That's it?
Let's go. No, we're going to go through to 20. We're almost done though. Okay, this one now we have definite integral, so let's do our bounds. What's the integral of cosine? Use the chart. Sine, good. So it becomes sine x. We don't need the plus c because we're going 0 to pi over 2. So sine of pi over 2 minus sine of 0. Sine of pi over 2 is 1. Sine of 0 is 0. So it's just 1. Okay, let's do this without doing use of the, then I don't have to change my bounds. So what should I put on the outside of this? Because it's a 2x. 1/2. Integral of sine is negative cosine. We're going to go back to x. That means I don't have to change my bounds. Because I didn't do use of. I just integrated in my head. Okay, so we get 1/2. What's cosine of 2 pi over 6? Or cosine of pi over 3? 1/2. Minus 1/2, so plus 1/2. And cosine of 0 is 1. Did I do that right? No, I forgot my negative for this one. Right? Yeah. Okay, so we got negative 1/4 plus 1/2. That's 1/4.
So why is that any different from doing this? Why don't you change that?
Well, I could, but if I change this to u, then I would want to make this pi over 3 and 0, so that I plug pi over 3 in for u.
I'll just take your next.
Okay, no, it's because I went back to x, so these are x values, so I keep them the same.
Okay, so normally when you don't go back to x, that's just convenience, not necessity.
Yeah, exactly.
Why would there be a plus here?
Which one?
For the
Minus
For this
the
one?
negative.
Oh, yeah, because it's minus the negative 1/2.
Yeah.
Okay, 14. So the integral, this is 1/2 x. That's a linear function, so I'm going to pull out a 2. Oh, geez, we can't do that. Because I don't know the integral of tangent squared. Do you?
No.
Do you know the integral of anything? Oh, not du, do you? How do I change this? What does tangent squared equal? Yeah, but that's terrible. Don't do that.
Secant squared minus 1.
Yes. Secant squared minus 1, right?
Yeah.
By a Pythagorean identity, and you know the integral of secant squared, so this would be 2. What's the integral of secant squared? Integral of secant squared is tangent of 1/2 x. And then what's the integral of the 1? Oh, that's just minus x. some pi over 3 to pi over 2. That's gross. No, you actually have to plug it in. So 2 tangent of pi over 4, so that's just 2. Minus pi over 2. Minus tangent of pi over 6 is root 3 over 3. 2 times root 3 over 3. 2 root 3 over 3 minus pi over 3. Then we'll leave it there because we can't do anything more than that. Okay, now we're into some heavy duty integration here. What do you think I should do for 15? There's many ways I could do it. Pick a way and let's try it. Anybody can pick a way.
Wait, what's the question?
Oh, just tell me how to integrate 15.
So
What?
like you do equals sine 2x.
Yeah, we can. Okay, so that's not a linear function, so we're gonna have to actually do u sub, like full out. So what's my du? What is it? What's the derivative of sine?
Negative cosine.
No, positive. Derivative. We're working our way down. So cosine of 2x times 2, right? Okay. Do I have cosine 2x somewhere in my problem?
Yes.
Yeah, so this one can cancel with that one out here, right? Okay, so my integral, I'm going to change my bounds too. So what's sine of 0? 0. And what's sine of pi over 2? 1. Okay, my bounds are 0 and 1 now. And then this sine 2x is u. And then dx is now du divided by 2, right? So 1/2 du. Okay, that's nice looking. Let's integrate u. U becomes u squared over 2. From 0 to 1. And then we have the 1/2 on the outside still, so we get 1/4 minus 0. That's it, 1/4. Easy. Okay. What should I do for 16 now? We'll skip 17 because 17 is just like 16 with bounds. What should I do for 16? There's 2 ways you can do this one.
So it would be like cosine times cosecant.
Oh yeah, it could be cosine times cosecant squared, but I don't think that, because then it would be multiplication and I don't have reverse product rule yet until you get to unit 7. So we can't do anything that's multiplied together. Any other ideas? Anybody? Yeah, you could do that. You could make this cosine over sine times 1 over sine, right? And cosine over sine is cotangent, And 1 over sine is cosecant. Do you know that? Yeah, that is a negative cosecant theta plus c. There's another way you could have done that one. Like if I did u equals sine x, du is, what's the derivative of sine? Cosine x. So if I have this integral with cosine, then this cosine theta and that cosine theta cancel, right? Yeah. Yeah. And then so I can replace this and go integral of 1 over u squared d theta is just du. Integrate 1 over u squared and you get negative u to the negative 1, right? Plus c. And u was sine, so it's negative sine x to the negative 1 plus c, which is negative cosecant. But you get the same answer. So you can do that one that way. Okay, what should I do for 18?
Oh, wait, we're not doing 17.
No, we're not doing 17. 18?
Do the u with the x squared.
Okay, u equals x squared. Du is
2x.
2x dx. Nice, because this x is going to cancel with, sometimes I like just canceling to begin with. That x is going to cancel with that x. So dx is equal to du over 2. So integral of 1/2, the dx is du, and this is sine of u. Integrate sine and you get negative cosine, so it's negative 1/2 cosine. Go back to x plus c. Okay, 19. What should I do? U equals what? Root x, okay. Du is 1 over 2 root x, right? Dx. Anything cancel?
Yeah,
The root x is on the bottom, cancel. And so this becomes integral sine of u. The dx is
Look at the 1/2.
2 du, right? So I need a 2 on the outside because it was a 1/2 left over. Okay. And then we integrate sine and we get negative cosine, right? Go back to x with the 2 in front, so negative 2 cosine root x. And 20. Secant tangent is, secant tangent integral is secant, yeah, secant of 2x, but what do I have to put on the outside? 1/2, because the 2x is inside of secant and tangent. So when you're integrating, you need the 1/2 on the inside. Okay. You have an assignment now. Take out your computers.
Oh, no.
Yes. Log on to Delta Math. Yeah. You should have an account. You made one at the beginning of the year.
Yeah, I already use Delta.
You don't use Delta Math?
Seems like
I use it.
unnecessary.
It's helpful. Then you don't have to retake standards 5 times.
I don't really feel like you're targeting that.
Okay. Log in. Make sure it says email, but just use your username that you logged into.
Read that.
And then you're going to go to standard 15.
We just read
There's
AMSCO.
this thing which I